So again, guys, the average rate of change right here, that's the slope formula. But truly, just do change in y over change in x and just get on with your life. Just make it simple. Because this is going to be a baby tool to analyze other stuff. What we're going to do is we're going to find the average rate of change from this interval, which are x values. Then we're going to analyze the same function at a different place on the graph over here. Now, if you guys have a highlighter or a different color pencil or pen, please highlight that word interval. And then, will you please remind yourself, 99 times out of 100, the word interval means x values. So if you're taking the SAT, or if you're taking a college entrance exam and it's asking about the interval, look for the x values. It's the domain. Why do we always care about the x values? Because the x values drive the problem, drive the whole problem. Okay, so let's go ahead and find slope. Wait, those are x values. You need a y value. How are we going to get a y value? Yeah. So guys, when I give you the domain, I'm not giving you coordinates. Most of the time, you're going to have to use the domain to find your own coordinates. So we're going to take the -2 and the -1. Y'all just plug it in through your order of operations. Find the output. So when we find the output for this first one, don't forget you have a leading negative. So negative, and then -2 to the third, plus 3 times -2. That's going to be one of the y coordinates that matches -2. What does that turn into? What's -2 times -2 times -2? -8. But then times that negative turns into a +8. So this is a +8 plus -6. What's a +8 plus a -6? Good. All right, let's do it again for the other one. So don't forget your leading negative. So -1 to the third plus 3 times -1. What does this turn into? So that's a -1 with another negative. So this is a +1 and then a -3. What's a +1 and a -3? -2, yes. So let's write -2 here. And let's just change or find the change in y over change in x. So change in y over change in x. Okay, so remember our y value started out right there and then it ended up changing into that. What was the change that occurred to make it that? Mm-hmm. What kind of floor?
Positive.
-1. And then let's take a look at our x value. So we started over here at +2. We increased a little bit to -1. Sorry, -2 to -1. How much does that increase? 1. That turns into a -4. So let's get comfortable using our new little symbol here. Average rate of change from the interval -2 to -1. That just equals a -4. And that's going to be it. Any questions on what we did? Any questions? Yes.
Are we just sliding down the bracket?
We're just rewriting the interval in which we found it.
And then write the answer.
Yes.
And that whole box writes the answer.
That's how you formally write the answer, yes. Now we're going to do it all over again with that interval. Right, so over here, do you think the function is increasing or decreasing right here in the beginning interval? It is decreasing, write that down, right? Let's write that it's decreasing over here. What do you think the function is doing between 0 and 1? Good. Now let's really level it up. Now let's ask a question on a pre-cal level. So here's my question for you on the pre-cal level. So from this right here, what can you guess is happening on the graph? Let me show you what I'm talking about. So let's take the interval, the beginning of -2 to the end, whoops. What was the end value over here? A 1? Okay, a 1. Remember, you started out negative, then you turned into positive, and then think about what a graph looks like. Let's say that this is -2, and this is 1. Tell me everything you know about what's happening in between those lines. Everything you know. Those two lines.
It's increasing.
Yes. Is it increasing? Where is it increasing at?
Wait, what?
Where's it increasing? After the origin. Yes, it is. Good. Here's the origin. Decreasing before the origin. Okay. So if it's decreasing, and I guys, I have no idea what the graph is shaped like. I should have graphed it earlier. I'm not gonna lie, I don't know. So if it's decreasing, I mean that's a decrease, and if it goes to the origin, it has to go to the origin. And then what happens after it crosses the origin? Yeah. Kinda, yeah. It's kind of a problem, but remember, there's stuff like it's continuing. I have no idea. Well, I can't draw that, so it wouldn't be a function. But there's stuff going on over there. There's stuff going on over here. We just wanted to know what happened in between those green lines. Think about yesterday. If you had to label this right here, what would you label this as? It is the origin. But what's happening with that graph at the origin? It's a turning point. Is it a high turning point or a low turning point? That's all we know, because we blocked it off in between those. There could be a way low point over there, or whatever. I don't know. It could go down forever. I don't know. But I know right here, you have a relative minimum.
So, can we put arrows like on the ends of and this would be arrows?
This?
Yeah, but like on the top of it. See how we go?
If it started out negative over there and it flipped over to positive, has to be a turning point.